Okay, the other question I want to look at today is a polynomials question, still from 1998, question 4, this one. It goes into the double root theorem. It says, suppose k is a double root of the polynomial, show that f dash of k is 0. So that simply means that if k is a double root, then f of x must simply have as one of its factors x minus k all squared, and the other factors we'll just put together as one polynomial, call it q of x. So f dash of x then is going to be 2 lots of x minus k times, so differentiate the first times by the second using the product rule, plus differentiate the second and times by the first. So just the product rule there to differentiate that. Almost there. F dash of x is equal to x minus k outside of 2 q of x plus q dash of x, x minus k, because it has a common factor of x minus k. So therefore, x minus k is a factor of f dash of x, so therefore f dash of k must equal 0. So, sorry, missed that last bit, so there it is again. X minus k is a factor of f dash of x, f dash of k is equal to 0. So that's the first one. So part 2 says, what feature does the graph of the polynomial have at a root of multiplicity 2? So if we think that one through, we know that f dash of k, which is our root of multiplicity 2, f of k to start with is 0. So therefore, it's going to touch the x-axis. F dash of k is also equal to 0. So therefore, it's a stationary point. And with roots of multiplicity 2, what happens is that the function, the graph, will touch but not cross the x-axis. I like to think of it as basically the graph bounces off the axis. So it comes down, touches, doesn't cross, and goes back up again. And that's what happens when there's a root of multiplicity 2. Okay, so I've got this new polynomial, and it's divisible by x minus 1 squared. And it says find the coefficients of a and b. So the fact that it's divisible by this, and the fact that we've just talked about double roots, should give us a clue that we've got two things here. We've got this polynomial, 1 is a root of, and because it's a double root, then the derivative of this polynomial also 1 is a root of. So in other words, for part 3, I have p of x is equal to ax to the 7 plus bx to the 6 plus 1, and p dash of x is equal to 7ax to the 6 plus 6bx to the 5 plus 1. And I know that p of 1, which is simply a plus b plus 1, is equal to 0. Let me come back and correct this. When you differentiate 1, you don't get that. And similarly, p dash of 1 is equal to 7a plus 6b is equal to 0 as well, because it was a multiple root. So now I simply have to go through and solve those two simultaneous equations. And I'll actually let you do it yourself. When you do in fact solve them, you should get that a is equal to 6 and that b is equal to negative 7. The last one. Let e of x equal this. Prove it's got no double roots. That's an interesting one. I've got to prove somehow that it has no double roots. So I've got to prove the derivative can't have the same root as the original function. The way I'm going to do it is I'm actually going to assume it does have a double root. I'm going to differentiate it. And then I'm going to sub the double root into the original one and into the derivative, and show that that I can't make both of them be equal to each other. I'll show you what I mean. So let's assume k is a double root. Of this polynomial e of x. So therefore, e of k must be equal to e dash of k. Or an easier way to work with this would be to say that e of k minus e dash k is going to equal 0. So let's have a look at that quickly. Firstly, here's the polynomial up here. E dash of x is going to equal 1 plus x squared on 2 plus x cubed on 6. When you differentiate this original function, you should end up with this. So e of k minus e dash of k turns out to be, when I put k into this one here, 1 plus k squared on 2 plus k cubed on 6 plus k to the 4 on 24. All take away e dash of k, putting k in here, 1 plus k squared on 2 plus k cubed on 6. And that is equal to, if you do that, subtract them out, you get k squared on 24, which is not equal to 0. And the reason for that is that k cannot equal 0, because remember k is a root of the original function, and we can see straight away up here 0 cannot be a root of this function. It won't give me 0 when I substitute in. So if k can't equal to 0, k squared on 24 can't equal to 0, so therefore e of the k minus e dash of k is not equal to 0. That is, e to the k is not equal to e dash of k, so therefore there is no double root. All right, have a look over that one again if you need to, make sure you understand what happened there.